Hello children, welcome to My Dream. Today we are talking about the work power energy. Yes, as you know, work is said to be done when a force is applied on an object that displaces in the direction of force. Or you can say work is said to be done when a force or the component of the force is applied on an object that displaces in the direction. Work done can be either due to a constant force or a variable force. So first of all, we are talking about the work done by a constant. So work done by a constant force. Suppose a cart is being pulled by a constant force like this. Here you see the direction of force, direction of the force is along the string. The direction of the displacement is in the horizontal component, horizontal surface. So the direction of the force is not in the direction of the displacement. Here, the direction of the force is not in the direction of the displacement. So what we will do? You can make the component. Now the direction of the displacement is in the direction of the force component. So which can be write down F dot S. So F cos theta, which can be, here the work is done due to the component of the force, not due to the displacement. Got it? Next. Work can be positive, negative, or zero. Work done can be positive, negative, or zero. As you know, if you are throwing an object like this, or an object is falling freely, so in that case, work done will be positive. Work done will be positive for theta is equals to, theta is lesser than 90 degrees. Then work done is equals to F S theta is less than 90, then it is positive. Or डिस्प्लेसमेंट भी देरी हो रहा है because of the gravity, because of the force. Here an object is falling that produces a displacement S. Here the direction of force is in the direction of displacement. So you can write down Fs cos 0. Then you will get the positive work done. If you are talking about the negative work done, when you throw an object upward against the gravity, it means against the gravity means displacement किधर हो रहा है, और यू आर थ्रोइंग ए बॉल, वो किसी वॉल से टकरा के आपसे पीछे चली गई. इन दैट केस द डायरेक्शन ऑफ द फोर्स इज अपोजिट टू द डिस्प्लेसमेंट, और यू कैन से द डायरेक्शन ऑफ फोर्स इज एंटी पैरेलल टू द डिस्प्लेसमेंट. So you can write down Fs cos 180, which gives negative work done. Here it is, work done will be positive if theta is less than 90. Here theta is greater than 90. Work done can be negative if you are taking the theta, or you can say the angle between the force and the displacement must be greater than 90, then you can get negative work done. Work done can be 0. Work done can be 0 when an object is moving in a circular path the direction of the centripetal force is perpendicular to the motion of the particle. So in that case, work done is 0. So work done can be positive if theta, the value of theta is less than 90. Work done can be negative if theta is greater than 90. If a person taking a book like this and he is moving, in that case the work done is also 0. In all the cyclic process, for a complete circle, or you can say for a complete circle, the work done is always 0. In the cyclic process, again the work done is 0 because the net displacement is 0. Now we are talking about the work done by the frictional forces. force, or simply you can say friction. Now, work done by the kinetic friction. Kinetic friction. The force of friction that comes to play. The force of friction that comes to play when an object is rolling or sliding, that kind of the friction is called kinetic friction. Here, the force of kinetic friction. The force of kinetic friction is anti-parallel to the displacement. Suppose this is the object which is moving, and so the direction of the displacement is opposite to the force of friction. Which friction? That is kinetic. So work done by the kinetic friction, which is anti-parallel, so it will be the negative work done. This is the work done by the kinetic friction. As I told you before, the force of friction that comes to play when an object is moving, or you can say sliding or rolling. Now, work done by a static force of friction. There is a presence of the two blocks. One of them is A, another one is B. Here, the direction of B is in the direction of the force of friction on the lower part of A. There is the presence of the two blocks. One of them is A, another one is B. A इसके ऊपर रखा हुआ है. As that is moving, अगर मूव कर जाता तो कौन सा फ्रिक्शन लगता? काइनेटिक. स्टेशनरी है, ठीक है. Here the direction of the, or you can say just about to move. In that case, work done, the direction of the force of friction is in the direction of the displacement. So the work done is positive. Now, yes, work done by the friction on a table is 0. This is the table over which there is a block. In this case, there is no displacement of the table. with respect to the block, there is no displacement of the table with respect to the block. So that's why the work done is 0. Yes. Now we are talking about more about work. If a force is applied on an object, that displaces from the position R1 to the position R2. This is R1, this is R2, this is delta R. So in this case, this is delta R. And delta R can be written, as I told you in the previous lecture, R2 minus R1. Then you can write down R2 minus R1. If the magnitude of the force and the displacement both vary, then if magnitude of the force as well as the displacement both of them varies, then you can write down F is equals to Fxi Fyj Fzk. Or the displacement can be written x Axi Ayj Azk. It can be represented by S label. Then work is a scalar quantity, follows the dot product, so you can write down F dot S. So Fxi Fyj Fzk having a dot product Axi Ayj and Azk. I dot I1, so Fx Ax Fy Ay plus Fz Az. This is the work done when the force as well as the displacement, both are varying. Now, work done by the variable force. This is all about the constant force, work done by a constant. Now we are talking about the work done by a variable force. Work done by a variable force. When a variable force applied on an object Yes, applied on an object that moves from xi to xf. So work done by this is given by, here the displacement is, here the displacement is divided into the small number of small displacement. So you can write down f dot s. Here delta S is the area of the shaded region, area of the shaded region, which can be written down limit x tends, delta x tends to 0, summation of f delta x. So it can be written down like this also, f delta s xi x. This is the work done by a variable force. Okay, next. Let us talk about the kinetic energy. Kinetic energy. As you all know about the kinetic energy, kinetic energy is defined as energy possessed by an object by the virtue of its motion. This is due to the interaction of the molecules. Interaction of the molecules की बात कर रहे हैं, which can be write down like this also. It depends upon the two factors. As you know about the momentum, momentum is defined as it is the product of the mass and its velocity. So kinetic energy can be written in terms of momentum. If it is multiplied by m and divided by m, then you will write down m into v whole square, which can be written down p square by 2. Or P is equals to under root twice of kinetic energy into mass. Suppose a lighter body and a heavy body. Suppose a lighter body and heavy body have the same momentum. Which one has greater kinetic energy? A lighter body and a heavy body have the same momentum. Which one has greater kinetic energy? So kinetic energy is given by P square by 2m. ये तो बटे कांस्टेंट हो गए. So kinetic energy is inversely proportional to mass. So क्या दिया आपको? As mass of the heavy body is greater than mass of the lighter body, जिसका मास ज्यादा होगा उसकी काइनेटिक एनर्जी कम होगी, और जिसका मास कम है उसकी काइनेटिक. सो काइनेटिक एनर्जी of the lighter body is greater than the kinetic energy of the heavy body. If a lighter body and a lighter body and a heavy body have the same kinetic energy, then which one has greater momentum? So P is equals to, as I told you before, P is equals to under root twice of kinetic energy into mass. Here this one is constant for both the objects. So P is equals directly proportional to the square root of mass. जिसका मास ज्यादा है उसका मोमेंटम ज्यादा है. तो मास ऑफ द हैवी बॉडी इज ग्रेटर देन मास ऑफ द लाइटर बॉडी, सो द मोमेंटम ऑफ द हैवी बॉडी इज ग्रेटर देन द मोमेंटम ऑफ द लाइटर बॉडी. नोट कर लीजिए. यस मनीष, नोट कर रहे हो? ठीक है, गुड. नेक्स्ट. If the momentum of an object is increased by first 10%, second 20%, third 50%, fourth 100%, 200%, n%. These are the different questions. मैंने एक साथ ही लिख दिया. If the momentum of an object is increased by 10, 20, 50, 100, 200, n%, then what percentage increase in its kinetic energy? Then what percentage increase in its kinetic? ठीक है, पहले एक एलोबरेट करके समझा देते हैं, फिर ट्रिक्स बता देते हैं. ठीक है. Let the initial momentum BP P1 P1. So initial kinetic energy हो गई, initial kinetic energy KEI P square by 2m. How much percentage? that is 10%. Percentage increase in its momentum, that is 10% of previous, which is 0.1 p. It is divided by 100. So the new momentum P2 will be P initial, increase is this 0.1, which is equal to 1.1. So the new kinetic energy KEF P2 square by 2m. In place of P2, you can write down 1.1 P, that is 2m, square of 1.1, which gives 1.21, and P square by 2m, that is, so kinetic energy 1.21 times of initial. And you want to know the percentage change in kinetic energy upon original kinetic energy into 100, then KE change कितना आ गया बेटा? This is KE I minus KE F divided by KE. So this is 1 minus KE F upon KE I, that is 1.21. ऐसे लिखो इसको, KEF minus KEI divided by KEI. So KEF minus KEI into 100, so it will become KEF divided by KEI. So in place of this you can write 1.21 minus 1 into 1, which gives 21%. तो इसका आंसर आ गया 21, इसका आएगा 44, इसका आएगा 125, इसका आएगा 300%, इसका आएगा 8%, 800. If the question is reversed, if the momentum की जगह I लिखा हुआ, if the kinetic energy increase by 21%, का percentage increase in momentum क्या हो जाएगा? 10%. If the kinetic energy of an object is increased by 300%, then what percentage increase in its momentum? Then it will become 100%. ठीक है? प्रीवियस जो क्वेश्चन किया है उसके लिए मैं ट्रिक बता देता हूं. P स्क्वायर बाई 2, परसेंटेज इंक्रीज इन काइनेटिक एनर्जी 1 plus n by 100, there is a whole square minus 1 into 100. In place of n you can write down 10%. In place of n आपने कितना लिया? 10. So it will become 1.1 square of 1.1, 1.21, then you will get 21. Now, in place of n, if you are taking 100 100 divided by 100, 1 plus 1 2, square of 2 4, 4 minus 1 3, और मैंने बताया था 100% वाले का आंसर क्या बताया था। ये जो ट्रिक्स हैं किसके लिए, फॉर लेस देन 10%, फॉर लेस नहीं बेटा, फॉर मोर देन 10% के लिए, फॉर लेस देन 5 लिख लो इसको, 5 फॉर लेस देन 5%, तब आप डायरेक्ट फार्मूला यूज करेंगे परसेंटेज एरर वाला। परसेंटेज एरर में बताया था पावर पहले आ जाती है चेंज इन काइनेटिक एनर्जी अपॉन ओरिजिनल, देयर इज नो वेरिएशन इन मास, मास तो वेरी करता नहीं है, so 2 delta P by P into 100. If the momentum is increased by 1%, so the answer will become 2%. If the momentum is increased by 2%, so the answer will become। अब आप पूछ सकते हो सर हम इस वाले मेथड से क्यों नहीं कर सकते, तो बेटे वो कर तो सकते हैं, लेकिन यहां पर जो आएगा ना, जब 1% दिया होगा तो ये आएगा 2.01, 2.01% आंसर आएगा, राउंड अप करोगे 2 आ जाएगा, तो इसलिए हम इस वाले मेथड को फॉलो करें। ठीक है बेटा, नोट, वर्क डन बाय द स्प्रिंग, work done by a spring, work done by a spring, according to Hooke's law, the force is proportional to the distance. The force, the applied force is directly proportional to the displacement. F is directly proportional to this. As you replace the proportional sign, there is the force constant, or you can say spring, where K is the spring constant. Here negative sign indicates that, here negative sign indicates that the direction of force, direction of the acceleration, is opposite to the displacement. This is the spring initially at rest, as you are providing a force, there is a displacement. यहां पर क्या हुआ, एक ये जो एजेंट है जिसने ये फोर्स लगाई है, और ये वाली फोर्स कौन सी है, वो ये है। In this case, एज एक्स इंक्रीजेज एफ एजेंट जो फोर्स लगा रहा है डिक्रीज, और यू कैन से नेगेटिव हो गया। अनदर वन, आपने इसको कंप्रेस कर दिया, now the x is this. In this case x डिक्रीज कर रहा, x क्या कर रहा है, डिक्रीज। f क्या हो जाएगा, f एजेंट दिस वन will become positive. So these are the different methods to describe the extension or compression. According to the Hooke's law, the applied force, whatever the agent provides the force, whatever the person provides the force to that system, the direction of the force is opposite to the displacement, or you can say the direction of the acceleration is opposite to the displacement. And according to the Hooke's law, the force is directly proportional to the compression or extension. Now we are talking about the potential energy. Potential energy. Energy possessed by an object due to its stationary, due to its static, due to its stable position, or you can say when an object is at rest. When an object is at, so first we will discuss जनरली आपने ये पढ़ा है ना, जनरली आपने क्या पढ़ा है, mgh, where m is the mass, g is the gravity, h is the height attained by jet. Now initially that is at rest, certain height, initially the zero है. So potential energy is defined as the energy possessed by an object due to its stable stationary position. Now we are talking about the different cases. अगर बेटे सेम पार्टिकल की बॉडी है, कोई बॉडी है, सेम बॉडी है, पार्टिकल्स उस मीडियम के उसी बॉडी से डिस्कस हो रहे हैं, तो वो कहलाता है सेल्फ पोटेंशियल. If you are considering the two objects, if you are considering the two different objects, ठीक है, तो एक तो ये वाली बॉडी है, इसके अपने पार्टिकल हैं, दिस इज द सेल्फ पोटेंशियल एनर्जी, सेल्फ पोटेंशियल. इंटरनल भी बोल सकते हैं। क्या बोल सकते हैं? इंटरनल पोटेंशियल एनर्जी। If you are considering the two objects of the different material, इनके बीच में जो पोटेंशियल एनर्जी है वो कौन सी है? एक्सटर्नल पोटेंशियल। सेम पार्टिकल्स हैं, सेम बॉडी को फॉलो कर रहे हैं, whatever the situation of the molecules at the stationary position. If you are considering the two objects of different bodies, then that is the external potential. Now we are talking about the काइनेटिक एनर्जी को एक बार और डिस्कस कर लेते हैं। काइनेटिक एनर्जी, so work done is equals to F dot S. F is equals to MAS. In place of acceleration, you can write down delta V by delta T. And that is mv delta v. If you want to integrate like this, so it will become v square by 2 v1 v2, so it will give v2 square minus v1 square, which can be read down this way. This is the work energy theorem, you can see. This is the work energy theorem. As you know about the conservation of energy, energy can't be created nor can be destroyed, but it can transfer from one form to another. इसमें कुछ कमी है, क्या कमी है वो डिस्कस करें। Energy can't be created nor can be destroyed, but it can transfer from one form to another for an isolated system. The system must be isolated. And isolated systems are those in which ना तो हम एनर्जी दे रहे हैं ना उनसे ले रहे हैं. That type of the system is called isolated. Okay, ये बहुत इंपॉर्टेंट है. दिस इज द वन ऑफ द मोस्ट इंपॉर्टेंट थ्योरम रिगार्डिंग द जी में. इस पर बहुत सारे क्वेश्चन आते हैं. ठीक है, वर्क एनर्जी थ्योरम मोस्ट इंपॉर्टेंट. इसको आप ऐसे भी कर सकते हो, v स्क्वायर इज इक्वल टू u स्क्वायर प्लस 2s इनिशियली इफ u इज इक्वल टू 0 एट रेस्ट, then it can be written down twice of as. If an object is initially at rest, so s is equals to v square by या a is equals to लिख लीजिए. हाँ तो दोनों से ही जाएगा बेटा. a is equal to v square by 2s. So work done is equals to force into displacement. F is equal to ma. In place of a, you can write down v square by 2s into s. Then you will get work done is equals to half, which is change in kinetic energy. Either you can go through this or that. ठीक है, नोट कर लीजिए. मोस्ट इंपॉर्टेंट है, ध्यान रखना. Suppose a यहाँ आपने कोई पंप लगा रखा है, पंप, इसका मास ले लिया डेल्टा, दिस इज द डेल्टा एम, वी वेलोसिटी, एच हाइट, then you can go through the rate of flow, that is delta m by delta t. If we are talking about the potential energy, so delta m into gh plus half m delta m by v square. Delta m, that is gh, this is the, if you want to know the power, the rate of doing work is called power, dm by dt, मैं t लिख दो, उससे कोई फर्क नहीं पड़ता अभी तो gh so as we are talking about the power, वैसे तो हमने डिस्कस कर लिया, P is equals to W upon T, this is T, the rate of doing work is called power, work done is equal to force into displacement, so the displacement upon time gives the velocity, which is a vector. If the magnitude of the force and the magnitude of the velocity vary, then it can be written down fxi, fyj, fzk, vxi, vyj, vzk. Yes. As you replace the dot product, you can write down like this also. So, one of the most important thing regarding the work energy theorem, तो बेटे आपको कैलकुलेट बाद में करना है, पहले उसको समझना है। समझना क्या है? हमें ये समझना है कि यहाँ पर कंजर्वेशन ऑफ एनर्जी लगेगा या नहीं, किस टाइप की फोर्सेज लग रही हैं, कांस्टेंट फोर्स हैं या वेरिएबल। वन ऑफ देम इज द कंजर्वेटिव फोर्स, अनदर वन इज द नॉन कंजर्वेटिव फोर्स। ठीक है, कंजर्वेटिव फोर्सेज आर दोज which depends on the initial and final position. Conservative forces are those which depends upon the initial and the final position. For example, when we are talking about the gravitational force, there is the presence of the two objects which are separated by a distance r, which shows the initial and final position. Whereas when we are talking about the electrostatic force, that also show the initial and final position. So these type of the forces are the conservative. Now we are talking about the non-conservative forces. And non-conservative forces are those which depends upon the path followed. Non-conservative forces are those which depends upon the path followed. Like viscous force, friction force. These are the non-conservative forces. Now you just take a 5 minutes break. उसके बाद बातें करते हैं आपसे.
Hello, students. Welcome to the My Dream, the India's first ever e-learning educational platform where each and every topic is taught with what, why and how concept.
Sir, what is this concept?
Right question. Then can you tell me what is education? Education means not only to getting marks in examination but also to develop their mind also. That's why the My Dream is introducing the concept of what, why and how so that analytical skills of students can be enhanced as well.
Wow, sir. How nice it is.
Yay. It's a nice step by the My Dream to bring a revolutionary change in recent education scenario. Hello, students. Welcome to the My Dream, the India's first ever e-learning educational platform where each and every topic is taught with what, why and how concept.
Sir, what is this concept?
Right question. Then can you tell me what is education? Education means not only to getting marks in examination but also to develop their mind also. That's why the My Dream is introducing the concept of what, why and how so that analytical skills of students can be enhanced as well.
Wow, sir. How nice it is.
Yay. It's a nice step by the My Dream to bring a revolutionary change in recent education scenario. Hello, students. Welcome to the My Dream, the India's first ever e-learning educational platform where each and every topic is taught with what, why and how concept.
Sir, what is this concept?
Right question. Then can you tell me what is education? Education means not only to getting marks in examination but also to develop their mind also. That's why the My Dream is introducing the concept of what, why and how so that analytical skills of students can be enhanced as well.
Wow, sir. How nice it is.
Yay. It's a nice step by the My Dream to bring a revolutionary change in recent education scenario. Hello, students. Welcome to the My Dream, the India's first ever e-learning educational platform where each and every topic is taught with what, why and how concept.
Sir, what is this concept?
Right question. Then can you tell me what is education? Education means not only to getting marks in examination but also to develop their mind also. That's why the My Dream is introducing the concept of what, why and how so that analytical skills of students can be enhanced as well.
Wow, sir. How nice it is.
Yay. It's a nice step by the My Dream to bring a revolutionary change in recent education scenario. Hello, students. Welcome to the My Dream, the India's first ever e-learning educational platform where each and every topic is taught with what, why and how concept.
Sir, what is this concept?
Right question. Then can you tell me what is education? Education means not only to getting marks in examination but also to develop their mind also. That's why the My Dream is introducing the concept of what, why and how so that analytical skills of students can be enhanced as well.
Wow, sir. How nice it is.
Yay. It's a nice step by the My Dream to bring a revolutionary change in recent education scenario.
Yes. Now let us talk about the self-energy. energy due to the interaction of particles of the particles of the same body, that is called selfing. Or the internal gravitational potential. यही पूछ रहे थे ना मिस्टर मनीष, विचार वैसे लिखते बताओ. Energy due to the interaction of the particles of the same body. Body क्या होनी चाहिए? Different particles से इनके बीच में जो interaction हो रहा है, now another one, that is the external potential energy. कौन सी बता रहे हैं? External potential energy. External potential energy, energy due to the interaction of the particles of the different that is called external potential. Suppose this one and that one, U1 and U2, इस प्रकार ये हम इनके बीच में इंटरेक्शन हुआ, that is UI. Now अभी थोड़ी देर पहले ही बताया था, ग्रेविटेशनल पोटेंशियल, ग्रेविटेशनल potential you are considering an object like this. This is a negative, हम इनका gravity की बात नहीं कर रहे हैं, ये है U है 0, y that is of h. Then delta U is equal to f dy. There is a change in displacement from 0 to h, from 0 to y is equal to h. Understand? Now on the system discuss कर रहे हैं तो माइनस साइन लगा दिया, that is minus g dy from 0 to y equal to h. इंटीग्रेट कर दीजिए, डेल्टा y डेल्टा u from 0 to y equal to h. So u is equal to mg y unit 0 to h. Then you can write down mg. Note कर लीजिए, clear now? Beautiful. Now we are talking about the elastic Now we are talking about the elastic potential energy. Elastic potential energy. Yes. The elastic potential energy is given by delta U equal to F dot dx F is equal to minus Ts minus plus Ks dx. The limit आप अपनी तरफ से कुछ भी this will become f square by 2 and that is half Ks square minus 0. What it will become half Ks square. If you want to draw the graph between the potential energy and the UV extinction requirement, it will become like this. This is directly proportional to this. So this is about the elastic potential. In the next session, we will discuss the problems which is based on the work power. Okay?